Alright, so let's look at an example of evaluating the definite integral. So there are two different ways that you can do this. So the first way is that you leave the limits of integration alone and you do the antiderivative as if this was a indefinite integral, and then just keeping track of everything, all the limits of integration. Keep remembering that they're in terms of x, not u, and then back substitute at the end. So if we're going to do that, so let's pretend, so you start out either way, whichever method you use, and I'll talk about the second method in a second, but no matter which method you're going to use, you start out with pretending, just like any other definite integral, that it's an indefinite integral. So let's first figure out what u is going to equal to. So in this case, u equals 2x to the fourth plus 1, because that's our inside function. So du dx equals 8x to the third power. So du equals 8x to the third power dx. But how many x to the third powers do we have dx? We only have one, so we got to divide by 8 on both sides. So 1/8 du equals x cubed dx. So now we do our substitution. So if this was the indefinite integral, right, this would become the indefinite integral of 1/8 u to the second power du. Remembering we can pull that constant out, right? But in this case, because it's a definite integral, we got to have those limits of integration. Now, we haven't converted our limits of integration. We're going to leave them in terms of the original independent variable. But our integral's in terms of u. So you need to denote this. You need to say that those limits of integration are x equals 0 and x equals 1, because the variables don't match. Remember, unless you specify, it's always going to be assumed that the variable for the limit of integration matches the variable that you're integrating with respect to. So in this case, because we have changed what we're integrating with respect to, but we haven't changed those limits of integration, we need to specify that, and we need to specify that they are still in terms of x. You still have to write out, so you're going to have to write out all the way until we have something in terms of x again, x equals 0 to x equals 1. All right, so now let's integrate this. So integral of 1/8 u to the second power, so this is 1/8 u to the third over 3, evaluated from, so remember, no plus c because we're doing a definite integral, so we're letting c equals 0, right? So then this becomes evaluating from x equaling 0 to x equaling 1, because we're still in terms of u, right? So the variable still doesn't match, so we got to say what the variable is, right? And now we would back substitute. So this is, so solving it is the exact same as solving a indefinite integral, right? Back substitute, so this becomes 1/24, so the 1/8 times the 1/3, so 1/24 u to the third, evaluated from x equaling 0, x equaling 1, which then back substituting is 1/24, so u was 2x to the fourth plus 1, so 1/24 times 2x to the fourth plus 1 to the third power, all evaluated from x equaling 0 to x equaling 1. And so then let's do our substitution using the fundamental theorem of calculus now. So this becomes 1/24 times 2 times 1 to the fourth plus 1 all to the third power, minus 1/24 times 2 times 0 to the fourth minus 1 all to the third power. So this is 1/24. So 1 to the fourth power is 1, times 2 is 2, 2 plus 1 is 3. So we have 1/24 times 3 to the third minus 1/24 times 0 to the third. So 0 to the third is 0, right? So we end up with 1/24 times 27 sorry, this is 0 minus 1 to the third, so that becomes negative 1 to the third. So this becomes 1/24 times 27 minus 1/24 times negative 1. Oh, sorry, this is plus 1, not minus 1. Positive 1. And so we end up with 13/12 whenever you simplify. All right, so method 2 works pretty much the same way. The big difference is when you're doing your substitution, you're going to change your limits of integration to be in terms of u also, but then you do not have to back substitute at the end. So in this case, so same exact integral, so we have u equals 2x to the fourth plus 1. Du over dx is still 8x cubed. Du is 8x cubed dx. 1/8 du is x cubed dx. Since it's the exact same integral, that's the exact same. But now whenever x equals 0, we're going to use the fact that u equals 2x to the fourth plus 1. So whenever x equals 0, that means u is going to equal to 2 times 0 to the fourth power plus 1. So whenever x equals 0, that means u is equal to 1. Similarly, whenever x equals 1, then u is equal to 2 times 1 to the fourth plus 1. So u is equal to 3. So now our integral is going to become the integral. So everything else stays the same as what we've done before, right? So this is still going to be the integral of 1/8 u squared du, but we change our limits of integration. So whenever we had x equaling 0, now that means u, because we're in terms of u equals 1. And whenever x equaled 1, u is equal to 3. And so then now we integrate this like we normally would. So this becomes 1/24 u to the third power. Exact same integral, so same work that we did before to get there. But the only difference now is this is evaluated from u equaling 1 to u equaling 3. So we don't have, everything is in u. So we don't have to back substitute. We can substitute in for u at this point, right? Because these are our limits of integration are in terms of u. So this is just 1/24 times 3 to the third power minus 1/24 times 1 to the third power. And so we get our 27/24 minus our 1/24, which gives us the 13/12. So you should get the same answer regardless of which method you use. Typically, you're going to see me change the limits of integration to be in terms of u at the same time that I'm doing my substitution. It just works out a lot cleaner that way.